Alright, another draft physics video presentation. Like 1,500 of them or something. I don't know. It's been a lot of them. But they're getting better and better, I'd argue. So anyway, Mickey Farley, stupid asshole. Anyway, keeps making videos. So he makes some video, 4-minute video, claiming some sort of contradiction in how they've explained photons and electrons and how they can interact and all that crap. And it's just crap. There's no contradictions. The contradiction is in your own physics. And the fact that your physics is so technically incorrect and so imprecise and so underdone and so undercooked and so almost juvenile mistakes. So we have this thing called a photon, right? What does it mean? It doesn't mean anything because they didn't give it any definition. So the problem is even in their little wave theory, okay, even if you think a photon is a little silly wave, the idea is this length thing is a problem, okay? Because they just don't define what they mean. How long is the photon? You know, is it this much? Is it this much? Is it this much? How much does it take to make a photon? So I've pointed out that yes, photons are a little bit of a composite object. You can't just say photon and have some notion that there's a thing doing this. There's a photon. No, it doesn't work. They don't believe it. I don't believe it. Okay, so that doesn't work in either theory. So clearly what I've pointed out is there's forces in the universe moving the speed of light. And I've said this is the smallest stuff there is, the quanta of the force. So a photon would be something like, okay, do you want to think of this as a wave? Go ahead. I don't care. I think it's sissy, but go ahead. Be a sissy. The photon is made of composite bits, okay, at a frequency. And they travel through space, and they have something called polarization. That is, they don't travel through space on exactly the same parallel line. All right, I mean on the same line. They're all parallel, but it's not the same lines. Okay, so they have a width, and they call that polarization. Now you can call it amplitude, okay, if you want to, but they call it polarization for a reason. All right, so now once you have some idea of that this is a little more complicated. You can't use your little ABC blocks to spell this word. So the idea would be is that these little quanta that make up the photon are the smallest thing, very small. But the polarization is not so small. Okay, it's 500 nanometers for average light, and the average atom is 0.5 nanometers. So the idea would be is that the average atom, okay, you put 5 into 500 and it comes out to be like 2,000, right? Well, 5 goes in to 5 once, so it comes out to be 1,000, right? So 1,000 atoms of distance, you could say, for the average atom and the average visible light. So there's a 1,000 times difference in the size of the photon, polarization-wise, than there is the size of the atom. So the atom is very small. Now, you can assume that the electron is a part of the atom, and it's got to be a small part. You could even say it's a quarter of it. Who cares? You want to think of an atom as this, and you could say the electron is this half of it. Who cares? Even at that size, you still can understand that the polarization is 1,000 times, okay, bigger than that atom. So if you're going to use this light to see something, you can't see this, because if you shoot the light at it, all you're going to do is hit part of the wave, right? You're just going to hit part of your wave. Only part of your wave will hit the atom, and you're not going to get anything back. You're not going to get a reflection that's going to be... The entire wave is not going to come back at you as a reflection. You can't reflect light off of an electron. You can't do it as a practical matter. And the fact is that if you hit one of these little quanta, one of these little wave humps hits an electron, it's going to shoot the electron in some direction, and the photon's going to go in some other direction. Now those are all kind of known facts, and I've never said anything other than that. Now, yes, recently I discovered, the last 2 months, that this polarization thing, I said, well, holy shit, no one ever talks about it, but polarization is huge. You know, the photon is tiny quanta, yet this polarization thing is gigantic. It takes up a lot of space. So light takes up a lot of space this way. Little tiny space, you know, in terms of the actual quanta inside of it, the energy inside of it, little tiny bits of energy. So anyway, so the idea is when you say a photon scatters off of an electron, a photon doesn't do that. Okay, there's no such thing as a photon. There's a photon. It's a electron. Okay, that never happens. All that you can do is you can think of it in your little wave theory, just think of it this way. One piece of your photon, right? Your whole photon is this. One piece of your photon can hit an electron and it can scatter. All right, and then you can put a bunch of your little pieces back together. Way over here, you can put a bunch of pieces back together. But you can never deflect a whole photon off of one single electron. So we can only see a group of atoms. These atoms are very small. We can only see, that is, we can only send a coherent photon, one of these little wavy things, you know, will come at it this way, or in my opinion just little bits, right? These little bits will hit, they'll all reflect, bink, 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 in the right order, and essentially it'll just reverse the polarization. It'll come in this way, you know, hit the surface and come off the surface going this way, you know. And so the only thing we can see has to be 1,000 atoms big. We can only see a surface that's thousands of atoms in size with a single photon. And the only other option is, again, the scatter. We can scatter photons off a bunch of places and then put them back together in some location, but that won't give us information because everything will be scattered. That is, we'll see the same number of photons here as here as here as here as here. So anyway, that just to clarify, I've never said quanta doesn't affect electrons. I've never said, you know, I just haven't. This has always been the consistent argument. So it's just a lie to imply that I've ever contradicted myself, blah, blah, blah. In the context of the videos, it's, you know, if you play the content of the video, the substance of the argument is correct, and it's only when these people try to pervert that, you know, that there's any kind of problem. So anyway, so we made a second video where he's going to redefend bullshit. So, you know, let's play that one. I guess we can zoom past the bullshit part of his intros, which are pretty bad.
So get ready for that. First, I just want to play this video. So this is the video from Kenyon University, Ben Schumacher.
Right, so Kenyon University, Ben Schumacher. So again, this is the university that graduates 8 students. And they have a professor that they're paying, presumably some kind of decent salary. So you do the math and you figure out, well, what's the agenda of this university, right? 8 students can't possibly justify their budget. So what is it, a Christian university? I mean, what's the game? You don't have a physics department that graduates 8 students unless the students can afford $100,000 a year. So clearly something's wrong with that picture.
Physics professor there who made this video.
Christian propagandist there.
So let's just play this in full screen. So right now he has 2 slits open, and then he's going to...
Okay, so let's understand that the principle is when 2 slits are open, there's 4 times as much light where the little balls are. So I would argue 4 times. Maybe he would argue 3 times. I don't know what his argument would be, but the balls should be much, much brighter. So when there's 2 slits open, the little balls are much brighter, and this little place in between them should be much darker. Now the reason why there's little circles, you know, is because they got the laser too close to the slits, and so the laser isn't spread enough, and so it's not producing an even over the whole thing kind of over the slits, and so you're getting actual images of the little balls, right?
Cover one of the slits with an index card. And when he does, these dark bands, these bands where less light.
Real untechnical experiment, right? And the device he has a little option that allows him to do that very precisely. So why is he doing it with an index card? You have to ask the question, right?
Is reaching the board.
And you would imagine the single slit is pretty. The single impediment has to be fairly small. So this idea of you're sliding this card in there, the paper fibers alone could be creating interference.
Are going to become brighter. More light is going to reach those points.
Says him. Okay, we're going to get there. There we go. So this is the best they can do, right? I mean, this is the simplest experiment. It's only 2 slits and a flashlight, essentially, right? That's all you got. 2 slits and a light source, and some place to display it. Wow, real complicated experiment, and look how bad this is. Look how desperate it is. So this is the foundational nonsense for all of pretty much the woo of quantum mechanics is built into this experiment. Many of the physicists will concede that point. And so we're arguing over a principle where they're saying that, okay, there's light hitting a surface, okay, and that magically, okay, with one slit open, and magically when I open another slit, I let more light in, okay, that this part here, and this part here, and this part here, and this part here go dark, that there's no photons hitting there anymore, okay, and so that is a dramatic statement to make, that all of a sudden photons that were doing this and doing this and doing this and getting to all these places all of a sudden aren't getting to those places because I opened another slit. All right. And the point is, though, is that these places are 4 times brighter, 4 times brighter, and 4 times. Now, maybe by his logic, it's only 2 times brighter, but let's just say 4 times. For the sake of that's my argument. So, well, 3 times. Yeah, 3 times would be enough. So we just say 3. Yeah, I can change them to 3s. Yeah, 3. We'll just say 3 times brighter. So it's more than just adding the 2. It's not 1 plus 1, and that's how much you get. No, it's 1 plus 1 equals actually 3 in this case, because you're putting together parts, by my theory. But anyway, the point is these are supposed to be really quite bright when 2 slits are open, and this is supposed to be dark. So with that, let me just play his. But again, this is foundational to all of quantum mechanics, and this is the best he can do in providing me their proof. In searching the internet, this is the best he can come up with. As a, look, you have to believe. So this is their have to believe evidence. If you don't believe, I can insult you, I can call you a crank, I can insult your intelligence, I can do all these things, call you a truther, call you a science denier. I can call you all kinds of names because I don't accept this as proof of something. I mean, that's how ludicrous their argument is. That's how bad it is. I mean, if this isn't the Inquisition, what is it then? I mean, it's just as badly founded. He makes jokes about, whether witches float. And what is the difference here? He's saying he can insult me because I don't find this compelling evidence. Amazing. So this is the dramatic, look how dark it got. Yeah, well, it didn't. All right, so let's understand. This first off, we don't know what kind of auto exposure is on the camera. So, right, this is already a problem. Whenever you're doing this kind of stuff, filming it, you have to remember to turn the audio exposure off because it does screw up what you're trying to observe as a technical matter. It keeps recompensating for the amount of brightness, and so it fools you. But anyway, so that's another one of the obvious things. Like, the physicist has to have that explained to him. Shit.
Okay, and if we zoom in really, really close here, we can see the effect even more.
Yeah, so I don't see the effect even more, okay? Personally, I don't see how, yes, it got much brighter when I closed one of the slits in between, in this little spot here. I close one of the slits and it gets brighter in the dark spots. I didn't see that. So he's going to magnify it even more now. Yes, this is the brilliant part, right? But you'll really be able to see.
So we just saw it get brighter.
All right, so watch the two sides over here. Now, these are supposed to be getting 4 times brighter when the circles are there, right? 4 times, or at least 2 times by his own argument. So the two other sides are supposed to be getting twice as bright as the other thing gets dark. So for all the light you lose in one place, you're supposed to be gaining it in the other place plus more. Okay, so but do you see any of that? Watch this dark spot here, and watch this light spot. Watch this one. Watch this clump. See if they change at all. And if they don't, then obviously something's wrong.
Okay, so let's watch it again.
Let's watch it
We saw more light reach the point, so it's darker, now it's lighter.
Yeah, so what did you see there? Did you see any of this stuff change in any dramatic way? No, it didn't change in any dramatic way at all. And it's supposed to be more dramatic, right? It's supposed to be getting much brighter, in one state than the other. So, I would make the obvious argument that the only reason why you can't, what you're seeing is the audio exposure on the camera adapting to the bright spots and just measuring them. And so, yes, this gets darker because it compensated for this.
It's darker, now it's lighter again. Okay, so that should not be possible.
Right. Okay, so that's his evidence. All right. So we're to believe in magitons, their little, whatever it is, their whole little magical theory that the photons that never interact with each other anywhere else magically interact with each other when they go through a slit. Oh, that just totally changes my identity, and I totally change into wave functions, and I totally do some probabilistic math and figure out what. So I have to believe all that crap based on that as evidence. And he says I'm an asshole, an idiot, some kind of fucking cranky moron because, I don't find that very compelling. I don't find this picture of Mary on your toast all that fucking compelling, retard. You don't think you have to do a little better than that? You have a wooey theory of magic. And this is the evidence of your fucking why I must believe in your magic verse. And so let's understand this experiment is so simple, right? And in the text he's talking about an entanglement experiment, right? So they can't even get this experiment right. They can't even do this with any technical precision. And you trust them on LIGO and on their cyclotrons and all this other crap. You trust all of the assumptions they make about those experiments when they can't even make assumptions about this one that have any credibility. You can't get simpler. 2 fucking little holes and a flashlight, and they can't do that experiment with enough precision to come up with better than this, look at Mary in my toast evidence. All right. It's just pathetic. All right. Continuing.
If you assume that light is a classical particle.
So again, this whole argument that I'm arguing a classical particle, there's no such thing as a classical particle. This is your kind of language, this kind of crap you say, right? The photon isn't a classical particle in the sense that a photon isn't, as I've always pointed out, has always been a ray, has always been a composite. It's not a particle, fuckhead. So right there, and this whole idea of what classical is, when the classical description was Huygens. The classical description is full of wavy bullshit. So it's just such a lie. Oh, it's disgusting. They play these games. You're the one with the archaic theory, shithead.
And then it actually gets even worse than that, so let's watch
There
this.
is a piece of glass, which is a Ronchi ruling.
This is from MIT.
Black line.
Yes, a video I've played.
The
MIT
thickness
OpenCourseware.
of each
Yes.
black line is about 75 microns, and the
75 microns, so that is 75 microns. Yeah, so that's almost 1/10 of a millimeter.
spacing between the black lines
No, there's 1,000 microns. So it's insanely small.
Is about 125 microns. Is about 250 lines per inch if you want.
So it's a diffraction gradient. It's not a slit.
This is then the this wonky ruling, this piece of glass with all these narrow slits on it.
Right, so it's a diffraction gradient. It's not a single slit or double slit.
The screen is, as before, is 200 centimeters away, and again, the wavelength of light is 6,328 angstroms.
And there's a big lens there for some reason. See the big lens? Big lens.
So now, let's look at, first of all, let's close down the jaws, look at the screen, and see if we can see the single slit diffraction pattern. All right, here we have
the single slit diffraction pattern that physicists don't want you to know about. Okay.
Let's just play it. Let's just show it again. Okay. So yes, I've played Lewin with the adjustable slit, pointing out. Okay. So I'm just saying. So every time you draw it, you draw. So this is another part of, I mean, how big a hypocrite or a lying, duplicitous asshole do you have to fucking be? I mean, I can show every single physicist saying, this is the single slit. That's it. Oh yeah, a little blob here, little sign, blah blah. Every fucking single one of them. Never, 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 ever, 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 ever. You won't have a single clip of a single college professor ever, 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 okay, drawing it the way it is, which is this. Okay? No, ever. There's not a single drawing like this. That's what it can do. That's what a single slit does. Okay, so let's just point it out. I'll show you the damn fucking image again. Alright, so I'm just saying, you want to keep pretending that they're being fair to the evidence when they're not. They're distorting perspective for a purpose of their propaganda. So again, this is not some hump with nothing else happens. It's just this blump. That's it. No, there can be 50 of these. Lots and lots of them if you just open the slit. So there's no argument here that this clearly is not some sort of dopey diffraction pattern. It's clearly the same pattern that the double slit is made out of. And only somebody who is a duplicitous liar is going to sit there and say, no, I don't see that. Oh, no, that's diffraction, clearly. Yeah, no, that's not interference. That's diffraction. Some sort of weird diffraction, right? Not the common diffraction. All right. I mean, these people are just such liars.
Because this guy's a physicist.
the single slit diffraction pattern. I have to apologize because when we close down the jaws, we don't have much light. And so I hope you can still see the single slit diffraction pattern. Now, on the screen, we have the...
And as I pointed out, as you go smaller and smaller, what are you doing? Okay, so yeah, do it again. So let's see him debunk this fact. Okay, the fact that I have observed and none of the physicists ever talk about. Okay, that all that's happening, the only thing that's happening in these stupid fucking experiments is one single thing. There's point sources created. So if you make a slit, you create 2 point sources. You make 2 slits, okay, you create 4 point sources. All right, if you create more slits, okay, many slits, then you create many more point sources. And what's unique about these point sources is they have a distance from each other. Okay, this distance. They have a furthest distance, the 2 furthest points, and they have the 2 closest points. Maybe I should draw that in different color, the 2 closest points, right? And that's all they have, because all you're really doing is saying, I can just take a point anywhere in space here and draw a line. And then I draw a line from the other one. And all that this whole fucking thing depends on is the difference in the length of these lines. How many wavelengths of light are there in the distance between those lines? And that'll tell you exactly how many clumps of light you will get on the screen. This exact distance will tell you. So in this case, you have this creating the envelope pattern, the big pattern, right? The big wide pattern, this big separation between the blobs. And this, okay, because it has more notches, because it's a longer distance, all right, this one's creating the little pattern. All right, and that's the simple theory, and the same is true for the diffraction gratings, doing exactly the same thing, and you just pile those up, and the math confirms that the math that works is doing this. It's saying how far, what's the greatest difference between two lines. So this line and this line would be the greatest two difference, and then you just go right down. What's the second longest distance, the third difference, the fourth difference, and you finally get down to the individual little slits as the last one. And that's all it's doing. There's nothing complicated. You want to know how many bars there are? Just figure out how many bars, how many wavelengths there are between in the distance, and I'll tell you exactly how many of these little blobs you're going to get. Now you won't see some of them because they stretch it out, and they really should be viewing it, as I said, in a round theater. So one of the lengths is always the same distance. Okay, one length is always the same distance, and then you're just measuring how much change there is in this one. This one, it gets a little shorter, a little shorter, a little shorter, a little shorter. You know, it doesn't go over the edge quite as much until it goes zero here. So it's 1, 2, 3, 4, 5 wavelengths. You could go right around, and it's all quite mechanical. No magic involved.
Circles are the 5 centimeter markers, and the little arrow tips, as you can see, they mark the
So
zeros
what is he
of
proving with
the
this?
central
I
lobe
mean,
of the single
again,
diffraction pattern associated
totally
with
undisputable.
the 50 micron or so slit on this Ronchi ruler. So now what I'm going to do, I'm going now to separate the jaws to admit one more, the second slit. Now,
Okay. So right there we see dark bands where light had previously reached.
Alright, so let's play it again.
second slit. Now,
Okay. So right there we see dark bands where light had previously reached.
Yeah, well, I'll play this part. Let me play it ahead of time so I can know what he's saying, and then I'll be back. Alright, I think I'm back. Yeah, I just went through of the... So these little arrows right here are pointing to the end of the bright band, right? So you get that part. Alright, now he's going to say it's going to get dark there. It's already dark there. You can see that, right? It's dark where this arrow is. It's dark where this arrow is, right? So let's just, you know, that's how bad it is.
second slit. Now,
Okay.
So what did we see get dark? Now, if you could zoom in here, you just see that, again, this is all, you know, if you don't have the audio exposure on the camera, if the camera is going to auto expose, then it's going to change the exposure here, and so it will change the contrast. But you know, the simple point is you can actually see the light still between these bars. Now, you don't see a whole bunch of light here, but there is still light there. So I mean, he's just plainly wrong. I mean, you can look right at where those arrows are and you see there is light there. So I'm just saying, so this is, again, this is the evidence he's going to say is so convincing that you just can't deny it. You're a truther and a liar and a piece of crap, and you're a flat earther if you don't believe this evidence is just so compelling. No, it's not.
So right there we see dark bands where light had previously reached.
So he's pointing to places that we don't see dark bands. This is not dark here. There is a whole bunch of light in between these two, and there's light in between these two. So again, it's just relative. There's a relative change. Obviously, you open two slits, there's more light getting through, so these brighters got brighter. And so obviously this looks darker, but it isn't darker.
those of you who understand this,
But then if you open more slits,
as I bring in one more
even
slit,
more
now
dark
we have
bands
three
appear.
slits, and you can see that
So he says even more dark bands appear when you see there's even more bleeding happening here and here. Okay, so again, it's just more nonsense that anything went away, and now he's opening a diffraction gradient. So obviously this is going to get much, much brighter. He's opening more and more slits. Obviously, you don't see them if he, like I said, if you don't understand exposure on a camera, then there's no point in making this argument. But obviously, if the camera keeps adjusting to how much light is coming at it, it's going to make it look like it's getting darker because it's going to try to keep the brights the same level. You do understand that, right? If it's trying to keep the brights the same level, it's going to make the darks look darker. Duh.
The other side goes off. In.
Okay. So anyway, that should be enough.
All right, so he says that should be enough. So there, you're not a reasonable person if you aren't compelled by that piece of shit as evidence. That proves that where there was light, there's now dark. That pile of crap. Yeah, okay. No, I don't think it does. I'm going to keep continuing to assert that if that's your standard of evidence, then you are religious nuts. Okay, you do believe in Sasquatch and the UFOs and all the other crap because you'll accept crop circles as good enough evidence. There's a damn picture of them, for fuck's sake. Isn't that enough evidence?
To prove that light has wave-like characteristics.
So now he said to prove it has wave-like characteristics. I mean, even if you could prove that that was actually true, you still haven't proven any of this wave crap. You know.
For those who might argue that
And take a close look
these effects are due to photons interacting as they're traveling through the slit together, you could perform this experiment by shooting the photons through one at a time. Okay, and that's what...
No, you can't, actually. So that's another... See, so they just lazily say this crap, but they really don't have that experiment either. Okay, so they just lie about another experiment that they don't really have. Because they make this critical error, okay, of knowing what a photon one at a time is. You know, no such thing. You know, technically, we don't have the technology to do this one photon at a time. We don't have any mechanism that guarantees that we've shot one photon. And again, what's a photon? 6 of these things? 3 of these things? 500 of these things? You know, what's a photon? Anyway, they don't answer those questions, is what I'm saying. So anyway, obviously if you do this low intensity light thing where you just send very few photons, or you know, trying to send just one in space at any one time, right? Again, so we can't draw a photon as a little blob. We can't really do it because we know it's not a little blob. We know that it has a polarization and it has a length. Okay, 2 things that they won't talk about, but that's what it has. All right, so we know we have to have them in space somehow, you know, where their lengths aren't overlapping to say there's one photon at a time. So let's just understand that first, okay, that you have to have the lengths overlapping. Then we got this problem, the polarization is much larger, and so that breaks the whole idea too. But anyway, the point would be is if you want to do the experiment correctly, what you have to do is have a source of your low light, and then you measure how much of it hits the surface, right? So you just measure and see if you can get one photon to hit a surface all by itself. And then you put your experiment in, okay? So when you know you have light here, okay, it gets to this other surface without the slit, then you put the slit in. What they keep doing is putting the slit in first and then saying, when did I get photons? Because what I'll argue is if you have so few going through, and you actually are getting some light here, you won't be able to put the slit in. You'll get no light because too many of the photons are broken. There's just not enough photons to reconstruct a photon. And that's a simple truth, and that's what the evidence indicates, that this experiment, again, another simple experiment that physics hasn't done with any technical precision. 0. No written papers doing the experiment. Nothing.
What this demonstrates. Now, the point of...
No peer-reviewed papers.
mentioning this teach spin device is not specifically that this particular professor from Kenyon University used...
So he said it again. Okay, so he said it again. So I'll just point out, They graduate an average of 8 students a year. Now you just explained to me how you can afford to have a physics department, pay a professor, plus have any technology at all. You'd be able to buy $7,000 devices for experiments and all the rest of this stuff when you are only graduating 8 physics students. You tell me how that makes any sense. Unless it's an agenda college, and a college being funded for some other purpose, being subsidized by some other mechanism. Obviously, the physics department isn't paying for itself. I didn't hear about how Kenyon has, a great, soccer team or something. What's paying for it?
To make this video that we just saw. It's to demonstrate the fact that these are experiments that physics students can perform on their own and do perform every semester, every year.
All right, so he just said that we can do single photon experiments and that we can just on our own do these experiments where you're measuring subtle differences in the amount of light hitting a surface and all this other crap. When, again, we don't even know what, physics can't even do this photon thing right. You can't even figure out that you can't reflect it off a mirror reliably. I mean, you think it's possible to measure 1/10,000th the distance of a proton with a photon.
Right, so it's not some sort of an Ivy League, behind closed doors thing.
Then why hasn't anybody done it? If it's so fucking easy, why haven't none of your physics people, here you are making an extraordinary claim, and yet you don't even try to create ordinary evidence? Instead, you keep the evidence way below ordinary? You're just deliberately leaving the evidence shitty for the fun of it? Yeah, no. Sounds pretty lame. It sounds like you can't manufacture your evidence. That nobody with honesty and integrity will be able to do it, and so they don't touch it because they're too honest and they don't want to be a fraud. And the only people that'll attempt it are people who do have some old agenda, Dr. Quantum agenda, a video financed by religious kooks.
Something that anybody could do on their own if they are a physics student. And you could and this device uses a filtering mechanism. The way that works is that the laser goes through a crystal and
This is a completely different experiment, so I don't know what he's talking about here. This has absolutely nothing to do, with the device. So crystals, no.
goes through a beam splitter, and it goes to a heralding device detector. And every time a single photon...
Okay, so they can't even, like I pointed out, they can't honestly describe 2 fucking slits, and we're supposed to accept this troll's description of it goes through a crystal, and then some other thing detects one of the photons by the magic beam splitter again, right? The magic beam splitter, where it's supposed to be doing 2 equal things to 2 equal photons, when it's theoretically impossible that they could be equal after being split. Because the process of splitting has nothing to do with an equal circumstance. Reflecting off a mirror and passing by the edge of a mirror are 2 completely different events.
Which is this heralding arm. It sends an electrical signal to the camera so that the camera can open its shutter.
Right, so they're saying they can trap the same photon. So 2 photons come out, and now let's understand this crystal doesn't send them out parallel. It sends them out in 2 different directions. Then they have opposite polarization is the idea. But anyway, just all this crap they're saying they can do. So they can trigger a photon event, that is a collision inside of the... when we know that a photomultiplier depends on a cascading event. It's an event that takes who knows how long and never takes the same amount of time. All right, because you're basically moving electrons. So through the whole process, you're hitting a certain number of electrons, moving more electrons, amplifying how many electrons you move. So there'd be no precision in terms of a timed event. There's no way this device could ever trigger exactly when the photon traveled this X distance to the triggering device. The device is just as slow. It's moving, the electricity in it has to move at less than the speed of light, because it's not moving in straight lines inside the detector. You could some kind of argue, right? Every time it passes through any piece of glass, it's slowed down. Lots of different things that you'd have to account for every one of those changes and say that it always happens reliably. That you could, and then send it through a wire to trigger another device to say, I'm supposed to look for a photon right this second, right this billionth of a second. Nowhere less, nowhere more. Just at this billionth of a second in time, I'm going to look for photons, and then I'm going to stop looking. So I'm going to blink my eyes so fast. Now, you really believe they have technology that can do that? That, you know, they can turn on a ICCD camera, okay, and have it turn on so instantly, you know, that it could detect the difference between a photon that was 1/1000th of a second later than the other photon. Oh, I say bullshit.
So it's actually filtering photons that were not fired from the laser. Okay, and it's an easy to understand mechanism.
Oh, there's nothing easy about that, but that is not this device. So I don't know why he's showing this when that's not what this is.
But again, just as I already mentioned before, you don't have to use a filtering device. Veritasium's video didn't use a filtering device, so there was noise, but the result was...
No, the filtering device is electronic filtering. It's not a filtering device with a crystal. It's electronic filtering. They're just saying if the photons come too quickly, it means they're not single photons at a time, therefore we can't count those results. It's, you know, that's all the filter's doing. The filter's just saying, I'm going to eliminate photons that are too close to each other in time. So I'll draw a circle for a photon. Now, we all know that's not a photon, right? That's really a longiton. Okay, it's really this. Okay, it's a whole bunch of stuff, not just one little thing. So anyway, but there's a photon here in space, in time. And there's a photon here in space, in time. And all the filter is doing is saying, look, if two photons are too close to each other, right? If this one's here instead of here, okay, then it records it because there's enough space between it. There's this one's far enough away, this one's far enough away, so they're recorded. This photon's recorded. But if two photons show up too close to each other, it kills both of them. No photon. So you get the idea that obviously with that kind of filter on, the more photons you're sending, the more photons being received, it could be troublesome because if they're not at the right distance, most of them will get destroyed because they'll now be too close to each other. So you could see how the filter could just end up eliminating the signal.
Still incongruent with a classical particle pattern.
Okay, so he said classical particle pattern again. Like again, I've asserted for the 10 years I've been making these videos, I never asserted otherwise, that a photon was always a composite object, that it always had a length, that it always had bits inside of it. So this is again just bullshit. Okay, the quanta is a composite, is a classical particle. So until you deal with the photon as what it is, a composite of composite quanta, you're just lying about what I'm saying. That's all it is. It's a clear lie to say that I think a photon is a round thing, okay, that flies through space. That's a lie.
Okay.
A round thing. It's a group of little round things.
So actually, let's go and let me just go into this in more detail. The idea that a photon and an electron cannot. So let's say we have a double slit pattern here.
Already.
Now Gary has said in other video, in one video that, or in many videos actually, that the photons go through
liar.
this one of the two slits, and it only goes
Liar. Right? It's just, you know, whatever.
through one or the other of the two slits. It interacts. Some of them will interact with a free electron and be deflected. Okay.
All the ones that go near the surface are doomed. Just like light reflects and refracts off surfaces, they just can't avoid the electrons. They do hit them and they do get scattered. So the quanta of the photon scatters. I mean, I made it clear. just make it clear once more. And again, in the past, I had different understandings of what a photon, how a photon would interact. And I kind of thought that a photon could interact with an electron, a whole photon. But because I just didn't think about the fact that the polarization is huge. And when I realized the polarization is gigantic compared to the size of even an atom, I realized that theory is silly. And you should realize it too. I mean, just, realistically, the polarization of the frickin' photon is 1,000 atoms high. Okay, it's gigantic. And for you to say that this photon travels to a surface and it affects one electron only, not all of these electrons, no, one fucking electron, and it vibrates it. And then it creates a new photon, another gigantic thing. Now, don't you see how that's just totally unrealistic? And, physics gave you that impression because physics doesn't talk about how gigantic this polarization is. It doesn't talk about how long this thing is. It doesn't talk about any of the features of this thing called a photon. All right? And the truth is, if you were to draw it as a classical particle, you'd have to draw it gigantic compared to atoms. And clearly gigantic compared to one little electron. This giant thing, you're thinking, is going to hit just this one electron, and this one electron is going to vibrate in a special way that creates one big giant thing. I mean, it doesn't make any sense. So clearly what I'm asserting is that the photon isn't that big giant thing, but the photon is in fact little tiny things, but they're created by an antenna, just like all the other kind of energy, so each is at a different parallel path. And that's the polarization. And when it hits the surface, the quanta is in, it has its frequency. And different bits of the quanta hit different electrons. Okay, so this one might hit this electron. This one might hit an electron on this atom deeper in. And now the phase is going to get screwed up. But each one hits an electron, gets scattered, moves in some new direction. Okay, and then all the scattered bits end up going somewhere. And the simple fact is that you can recombine the scattered bits into in phase, out of phase, in phase, out of phase. You can make a new photon where they're in phase. You can't make one where they're out of phase. You make one where they're in phase. You can't make one where they're out of phase. And that's what happens. Blah blah, that model does work and does explain. Now, if you want to say no classical model, well, bullshit. That model works. Deal with the one I'm suggesting, not one you've made up. I mean, it's just such obvious straw man crap.
And some of them will just go straight through. Some of them will be deflected that way, and then of course the photons that go through here do the.
So again, it's not the argument. I keep talking about I've been talking about the surfaces for at least 5 years. The surfaces, idiot. So these lines come off of the surfaces, fucktard. That's my theory. The surfaces are scattering. Light that goes through goes straight through. Light that goes near the surface scatters. The bits of the light.
Same thing, and that's what accounts for the double slit diffraction, the double slit interference pattern, as well as the single slit diffraction pattern. And the problem with that is, as we have just seen, more dark bands appear when you open a second slit.
Okay, so he said it again as if they've proven that. It's a demonstration, it's a fact, where you have to accept it. So again, there's no point in arguing with somebody who thinks he provided convincing, overwhelming evidence. I have to believe it. His evidence is just overwhelming. And I just pointed out how underwhelming it is.
Or if you open 3 slits or 10 slits, every time you open a new slit, more dark bands appear.
So, more bullshit. No, they don't. It never happens, blah, blah, blah.
Which should not be happening if this mechanism is in fact the one true explanation for the phenomena. He also said that
So amazingly, he's perfectly satisfied that he's proven it. With those horrible images, he proved it. Shit.
He said that physicists lie about experiments. He says that they lie
I've proven they lie, okay? In the sense that obviously when they talk about a detector experiment that never took place, that there's no documentation for, there's no written paper in the annals of physics history documenting the experiment, well, yeah, then I guess that's lying.
And say that an experiment has been performed that determines which slit the photon went through. This has been done. It's called the quantum erasure experiment.
Okay, so here we go for a much, much more complicated experiment, right? So much more, all kinds of technology applied, and he's saying, okay, so we did detect photons without changing their path. No, they never did do any of that. So it's just more horse shit. They're using the polarization filters, which again, they don't even understand how they work. Again, so they can't give you an honest description of the simplest experiment, and you're supposed to believe them on the more complex ones. That's reasonable. It's reasonable to believe somebody who can't spell, like me, duck, right? But you're going to accept their spelling of hippopotamus. No, that would be stupid.
But he says the physicists lie about that. And one of the arguments he uses to demonstrate.
One of the things I do to demonstrate is I play the fucking lectures. I play the physicists just making the crap up, just saying all the crap that they're told. My teacher told me so. I don't have to have evidence for any of this crap. I'll just tell you this is the truth, even though it's not the truth.
And I use that term in the loop.
I'll draw this silly drawing of a single slit pattern. Look, it's only got 3 humps in it. Single slits are lame. No, they're not. Just open the slit and you'll see it ain't so fucking lame.
Loosest sense of the word. One of the arguments he uses to demonstrate that this is impossible is he says that photons are much too large to interact with electrons or to be deflected by electrons.
So that's just a lie, right? It's a horrible, stupid lie. The resolution of a photon is way too big to see something as small as an electron. You can't reflect a single photon off of an electron. It's impossible. That's the assertion, shithead. The quanta hits the fucking electron, and the electron is moved by being hit by quanta. That's all electrons do, is sit around all day saying, wait for a force bit to hit me so I can move. That's their whole life, is being jiggled by force bits.
You could never use some sort of a electron. I don't know. Maybe he's.
Yeah, you could never do what Feynman says. Oh, I could turn the light down really low and, shoot photons at the electron and wait for a reflection. You can't do that. That's right. You can't do it for 2 reasons. First, the quanta of the photon will change the path of the electron, and second, you can never do it because the photon quanta can't all hit one electron. Not possible.
Thinking of an electron microscope that's like shooting electrons out and detecting the photons.
That's not what an electron microscope does, so that's a pile of horse shit too, right? Electron microscope actually moves electrons. It flies them off of a surface and then sees the electrons like it sees light. Okay, it takes a picture of the position of the electrons.
I don't know, but shouldn't the electrons bounce off of the photon? I mean, according to real physics, a photon is an excitation in the electromagnetic field.
Yes, whatever that is.
And electrons actually
the magical wooey-verse.
Absorb that energy.
Yes, electrons absorb energy. That's all they do all day. Something hits them from the right, and they go, oh, I have to go right. And then something hits from the left, and they have to go left. That's all they do.
And move into a higher state of excitement. But according to his theory, who knows what happens when a photon interacts with an electron? He's never...
Yes, I have. I just drew it now. You want me to draw it again? Yeah. I'll draw it again. Electrons are always bound. So free electron is a bullshit word. Okay? Electrons always can feel the charge of the universe. So no matter where an electron is, if there's just one tiny plus charge way over here and one extra minus charge over here, the electron will sense that. So there could be zillions of them, and they all balance out, except for these 2 are not in balance, obviously. and the electron will say, I'm going this way. So the electron always is, if it's not going somewhere, okay, then it's in balance. That is, wherever it is has been created, a balance has been created between a positive charge and the other negative electrons. So it can be in a position, so I could have a negative electron there and an electron there, and then there could be another electron that would stay right here, and it would be in balance. That is, it's attracted here, but it's repelled in these two directions. And there's a balance between that force and this force. And so the electron is in that position. Now, if I hit it with a photon is going to be this little tiny thing, the one quanta of the photon. Okay, so there's other quanta over here, and there's one went over here, and there's one went over way over here. All right, I mean, way over, I mean atoms over. Okay, so, and one quanta will hit the electron, and it will give it some momentum. Now, the problem is it's in this tension. So what the electron's going to do is move in kind of a funny way, because it can't get closer to this electron. So if it moves straight, it's going to end up closer to this electron. You see this line? Okay, it can't do that. It can't go straight, because then this line gets shorter, you see? More repulsive. So the electron will probably move this way. All right, and the photon, okay, it's going to scatter. That is, the quanta will leave the electron, okay, when the energy from the universe fights back and says, I'm going to repel that energy. And so then the photon will end up getting a reflection, and then it'll end up shooting out. But anyway, let's just say for the sake of argument, the photon will end up going this way. So the photon's trajectory was changed. The electron's position was changed. The electron's going to move back again. And this would be the argument for the photoelectric effect. Is the key to the photoelectric effect is if you can hit this electron twice, that is, you move it to this position, and then you actually hit it with another piece of quanta, okay, another little piece of the photon, then you can knock the electron free of the atom. But otherwise you can't. Okay, so you have to hit it twice. All right, so I've been over this stuff. That's how it interacts. So the photon is, again, gigantic. The quanta is spread over a gigantic field of atoms, and all that ever interacts with an electron is one little tiny portion of the photon. One portion of it. So if the photon was 6 of these things, or 7, only one portion at a time can interact with an electron. Only one portion at a time. Different electrons have to hit, these things have to hit different pieces. Okay, so that's what I've said. That's what I've illustrated. That's what I've drawn. Why does he have a problem understanding? Oh, that's right, because he doesn't want to understand. He just wants to pigeonhole and call me a Nazi. You know, he doesn't want to sit there and play by any kind of fairness rules.
Actually fleshed that out. But regardless, he is on record stating unequivocally that, first, photons and electrons can't interact at all.
Lie. Okay. So, I mean, clearly, as I just stated, the interaction has to be understood in a more precise context. A whole photon cannot hit a single electron. That's what I've said, okay? So he says unequivocally. No, I've said it very equivocally. I've said it very conditionally. I've pointed out a photon is not a one round thing. It's a composite of things. And one element of a photon interacts with an electron, not the entire photon. That's what I'm saying. That's what I've said. That's what I'll continue to say. And you'll just continue to lie.
So therefore, we can never perform this experiment. And then he changed it and said, no, wait, I was talking about the double-slit electron experiment where they're shooting electrons through the double slit. So now...
That's a lie, too. Doesn't matter. You can't detect a photon, okay? Detect in the sense that you can't passively interact with a photon ever. All you can do is scatter the bits of the photon. You can interact with the bits of the photon. And when you do, you change them dramatically. Period. That's what I've said. That's what I continue to say. There's no passive interaction. There's no, I can detect the photon's path without changing its path. That can't be done. And it's also true that it can't be done with electrons either, because electrons are just as sensitive. They're small compared to the actual size of the actual thing called a photon.
There's not a double slit pattern. It's not a double slit experiment performed with photons. Now all of a sudden it's a double slit experiment performed with electrons, which, by the way, also exhibit an interference pattern. So, one might ask what...
This also might be a good place for an argument, because we have such mixed data on the electron experiments. So, again, another thing they haven't done. They just don't do these experiments very much. And so, the one I've seen that's, sort of, it gives kind of classical results, the one I was even linking to because I thought it was photons, it does show a double slit pattern, in the sense that it does do, the breaking of the bars. Now, that's the only electron experiment I saw. Most electron experiments, if you go Google it, you'll just see this kind of thing, a bunch of bars, and it goes light to dark and light to dark and light to dark, and that's all you see. So this one is kind of unusual because I've never seen it with these breaks in here, in these positions. And so the question, though, is that when you're doing these experiments, obviously if you're putting electrons through a classical big slit, part of the catch would be is that when you're shooting electrons, you're also shooting photons. Okay, there's lots of high energy photons that go with shooting electrons. You can't shoot an electron without creating some X-rays, some ultraviolet light, some different kinds of high energy photons. So the very process of shooting an electron requires you to create a lot of heat. You have to heat an element, and they glow, and especially when you're doing it with electrons and putting voltages in and all that crap. So the point is that maybe they're not actually detecting electrons, but they're just using a phosphorescing screen. And high energy photons will also light the screen up, not just electrons. So there's a real problem there if you're shooting light at the screen, besides just shooting electrons at the screen, and they both light the screen up. Yeah, there's a flaw in your experiment, frankly. That's a problem. I think it's a problem with a lot of these experiments, especially accelerators. The accelerators are relying on this idea that they're pushing electrons with energy. Well, what's the energy? Well, the energy happens to be photons. The X-rays are what's actually pushing the electrons. And so, and they're clearly there. That's why they have to put up all kinds of barriers to prevent themselves from being X-rayed by the radiation they're creating in accelerating the particles. So they're creating a whole bunch of radiation. And then they start measuring the speed of electrons based on how much, or the mass of the electrons based on how much heat they're creating at the target. Well, the heat they're creating is because they're shooting a bunch of X-rays at the target. So I just say that you can't trust physics. You just can't. Again, and it's so obvious in the sense that they can't do the single slit thing right. How can you trust them? They can't get that right. Light going through a single slit, and they can't do an honest job of showing you what happens. If they can't do that right, how can you expect them to do all the other stuff right?
What causes the electrons to deflect? The other electrons? I don't know. He never actually explains that. But the point is...
Show me good data, and I'll try to explain it. But I'm just saying that's just a problem. The electron experiments are mushy. Okay, so if you have some source of a lot of good electron two-slit experiments, fine. But the ones I've seen all have a lot of mush in them.
His argument is that you can never take a photograph of an electron passing through the slit, and therefore this experiment has never been done because the photons are too big. If you try to take a picture, the electrons would, according to him, okay, not according to real physics, but according to him, what would they do? Would they bounce into each other and then the photon gets deflected 3 degrees? Or would a photon go through the electron and not interact at all? Or would the electron bounce off of the photon and go in the same direction?
I've said it dozens of times. I said it's all basically just Feynman diagrams. I mean, that part we agree on. I mean, electrons and photons interact. Now, what is in a Feynman diagram? Is it a whole photon? I would argue it's not. Quite obviously, it's a quanta of a photon. There's no squiggly line hitting the electron over a period of time. So I'm saying none of that is happening. You think it's happening? Fine. How do you explain it? How do you explain something that has this gigantic polarization that spreads over thousands of atoms, how do you explain how that gigantic thing hits one electron to make a Feynman diagram? How do you explain it? Unless it's quanta. The quanta hits the electron. A piece.
These are details he's never explicitly
Oh, bullshit, I haven't.
fleshed out in any way at all. But, there's
Except drawing a picture of it. I mean, again, it's just he's so dishonest. I mean, I've pointed out this relationship between refraction and this concept of what's happening when you're making a smaller and smaller slit, right? When you make a slit smaller, right? You have a big slit, the light has a low probability of going near the surface, right? I make a small slit, there's a high probability the light goes near the surface, especially if we know this light has a certain width to it, right? So the smaller I make the slit, the more likely the piece of the photon is going to hit the edge. Now, I've pointed out that refraction of light, light hits the surface and then it bends a little bit. Well, it bends a little bit because of what I just pointed out before, that every electron is in tension with a proton and the other electrons. So the electrons are pushing away and the proton is attaching. And so when you hit the electron at this angle, it has to move in this direction. Okay, so that's what's pushing it towards the normal, is the fact that the electron doesn't have a choice. It can't go this way, so it kind of has to go that way. And the same thing would happen if you went across the surface. So if this was the side of the slit, I'm saying there's a bunch of electrons on the surface of the slit, and the light has to travel through those. The same electrons that would diffract light if it was going in is the same kind of energy is going to cause this photon, the pieces of the photon that actually go here through this area are going to hit electrons, and they're going to be scattered by the events of hitting the electrons. They're going to move the electrons in different positions, and that's going to cause the light to leave in all kinds of different positions and angles, and that's what you end up with your result. The light is scattered by the surface, is the argument. Scattered. Doesn't have to come out at a specific angle. I've changed, modified, improved that argument. You won't accept that improvement. You won't argue the real argument, and so you suck.
Just that soundbite where he says a photon will never be deflected by an electron. But then...
So, more bullshit. So that's not a quote from me. A whole photon won't be deflected by one electron. Yes.
That contradicts his explanation for the pattern.
No, it doesn't.
Which is just lunacy. And by the way, it's even more lunacy when you think about his actual theory in detail. Like, what is a photon in his theory? A photon is a collection of...
Oh, so now he's going to pretend. So the whole time he's pretending he doesn't know that I've called it a composite particle. And all of a sudden now he's going to concede. I call it a composite particle. Isn't that amazing dishonesty?
Tons. Right, so maybe there's a collection of tons, and they're all moving in the same direction, the speed of light, and it has to go through one slit or the other. So here's one slit, and of course this is not to scale.
Right, the scale would be the photon is gigantic. Well, it really isn't. To scale would be the wavelength. So yeah, why don't you draw it to scale? So this is 500 nanometers of width, and so the question is, how many of those nanometers are you going to have in the width of this slit? So a micrometer would be 2,000. Photons could fit in a micrometer. 2,000.
Oh, but whatever. I mean, he never actually... How does he know a photon is 100 times bigger than a molecule, or an atom, rather? Or a molecule, or whatever? How
do I know? Because I looked it up, okay? I mean, if you want to argue, it's fine. I looked it up to say how big is an atom. The average atom is 0.5 nanometers. You disagree? Fine. It's okay with me. You want to come up with some other number? Fine. What do you think the number's going to be? 0.7? 0.8? I don't care. Pick any one of them. The point is that the photon is still thousands of times bigger than an atom.
Does he know any of that? Because does he have to rely on the lying scientists and their lying experiments? Or does he just take it on faith? Or
No, I'm just taking it on the facts too. Yes, you can do some kind of experimenting to figure out how many protons are in something, and then how many, So there's some way to figure out the charge of the atoms and separate the charges, but you can't do it with photons, clearly. Photons aren't going to tell you very good information because you only see a clump of atoms with a photon.
Did he stare into his navel and go, "Oh yeah, that's the correct answer, that one true"?
Who cares? Make up your number. You tell me what the number is then. Okay? Yeah, I don't trust your physicists. I think they are assholes and idiots. But you go ahead and give me the number and I'll explain based on your number. Because your number is certainly not going to be a millimeter, right? We know the atom isn't a millimeter across. We know that. Shithead.
Explanation, who knows? But regardless, so if this is a photon, here there's a free electron, and a free electron is maybe it's a circular orbit that's square shape. Maybe it's a ton caught in a circular.
So that never did I ever talk about orbiting electrons or any kind of crap like that on the surface. So just more lying. So he can't ever paraphrase honestly. Never did this. Never said there's orbiting electrons on the surface. Never said any such thing.
Square orbit like that. So then when this collection of tons interacts, somehow all of these possibly millions of tons, or is it billions of tons? Is it 10 tons? Whatever, who cares? That's unimportant. The point is,
again, using your own physics estimation, they're saying it's 6 or 9 for a human eye. Bits, quanta. The thing Einstein invented. Quanta. Clumps. But he has to call them tons. Okay, you want to play little games? Fine. Wavicles. Why don't you give me your little wavicle theory?
it's a collection of tons, and somehow this interaction here, whatever this is, causes all of these tons unanimously to change direction. And they don't change direction by scattering.
Oh, no, that's exactly what I said, scattering. Yes, that's exactly what we've been saying for the last month, scattering. So, again, just lie some more. I mean, I've said the word scattering related to the surfaces hundreds of times in the last 2 weeks. Hundreds of times.
They all change direction exactly 3 degrees, so this is...
Okay, so he's still doing it, right? Now, I've argued this at least 5 times now, where I said, no, that's the old theory. I mean, even if you want to go with the old theory, it still works, but I'm just saying, you don't need this complication anymore. It doesn't need to go 3 degrees. It's scatter. It goes in every single direction. All 180 degrees.
Exactly 3 degrees. Right, and then it lands somewhere on the wall over here.
I mean, look, anybody honest watching these videos, like the McCool guy, the mindless marbles, do you think this is an argument that has any kind of integrity? I mean, you're supporting this asshole with an argument. I've already refuted it over and over again. I've already stated overtly. You don't have to do the degree thing anymore. Okay? It's just scatter. And you just don't see the dishonesty of this fuckhead?
This is just absolute nonsense. It's incoherent. It's basically word salad. This is not an explanation. The explanation...
Yeah, well, yeah, the way you draw it, it's pretty shitty, but obviously I've drawn it much better than you. And again, I'll just say, look, refute this. All right? I mean, I've drawn this a few times, okay? It's getting horribly redundant, but this answers all the questions. This whole mystery of the 2-slit, mystery of the single slit, it's over. It's cooked. It's done. It's just about the distances from the surfaces. The surfaces are the point sources. They are creating the lines, the vectors. All right? And it's proven by the simple logic that this line to some point in space versus the length of this line to some point in space, that line goes from 0 to 90 degrees, and it goes from 0 difference to whatever the D equals. The D is the wavelength. D equals, okay, how many wavelengths fit in that distance is all that fucking matters. So how many lambdas you have inside that distance, that's the entire definition of how many little symmetrical blocks you will get in this arc. So if you just say, oh fuck to this stupid idea of projecting it on a flat screen, and you project it on an arced screen, I can tell you exactly how many of these little bars you're going to have for any slit width. I change the slit, I can tell you exactly how many of these there will be, because there's one per wavelength distance in the D. The number of wavelengths in the D equals the number of blocks you fit in this arc. And that'll tell you exactly how big they are. The bigger the smaller the arc, the smaller the little blocks. The bigger the arc, the bigger the little blocks. The block size is dictated by this distance, period. Doesn't have anything to do with any fucking waves. The end. Your theory is debunked.
That a photon is a excitation in the electromagnetic field and it exhibits wave-like characteristics explains the single slit and the double slit pattern. It's the foundation.
Right. It doesn't explain the single slit at all. Two waves are created by a single slit. Oh, too stupid. We're already done. Then why aren't four waves created in the double slit? So I've already asked these questions so many times. Okay, they can't apply their Huygens consistently if they're going to pretend, oh, it's wave diffraction in the single slit. Well, then why aren't there two wave diffractions in Young's drawings? Why didn't Young draw two diffracting waves interfering with each other? So there'd be four waves in his drawing. Why isn't there four wave functions in Young's drawing if that's the way it works? You lying, duplicitous creeps. I mean, how can you keep asserting something so fucking stupid?
The foundational experiment for quantum mechanics. It's the experiment that convinced physicists who had previously been committed to a particle-based theory to
name some of these physicists. So look, it all goes back to Newton. Who was after Newton? Oh, there weren't any physicists actually. They didn't assert anything, okay? And all of them were wave nuts. So this idea that somehow there was a ton of particleists out there who were trying to figure out a particle theory, we already know you dismissed Fadio and Lesage way too soon. Feynman's debunk was trivial. It's clear. You're all etherist, wavical god botherers. All right? You believe in your random thing. Some sort of angels are fiddling with the universe to make outcomes, match. I mean, you're just religious kooks.
Yeah, obviously we need to work on our theory and come up with a better explanation. And it has to include both particle and wave-like behavior. It has to
No, it doesn't. So again, this behavior part is just bullshit. All you have to explain it is understand that guess what? All of their mathematics has straight line vectors in it. The charge, Maxwell's mathematics is full of straight line vectors. It's not full of fucking waves. It's full of directions. Straight lines that energy travels. Straight lines are the basis of any curved line. It's even true in gravity. There are no bent realities. There's only straight lines. And if you see a curved line, it's because two straight lines are creating it. That's the reality. You don't need to reconcile wave phenomenon, because there is no wave phenomenon. Okay, there's just the vectors that energy travels. Even an ocean wave is full of a bunch of energy moving straight fucking lines.
Account for both of those behavior of photons. Okay. But yeah, I guess the question I would have is what exactly happens here? You have a collection of tons, and this is a photon.
So he does it again. He can't accurately describe it ever. Right? You just can't do it. I mean, I've drawn it so many times, and here he is dishonestly again. Is it that hard for you? Okay, it's so difficult for you to get it absolutely right. We know that because of the speed of light and the way photons are created, okay, that they have just as much height, okay, as they have distance between them. Okay, the two are at least very proportional. The wavelength is going to be very proportional. Okay, that's because of the antenna that's actually making photons. Okay, and the atoms are the antenna. A row of atoms are the antenna that makes the photon. The electricity goes through it this way. It shoots little bits in series, okay, from locations. Obviously, those little bits mean one bit will be ahead of the other bit, will be ahead of the other bit, will be ahead of the other bit, will be ahead of the other bit. Okay, so there'll be a polarization this way, and there'll be a consistent distance this way. So this is the frequency, okay? This is the polarization. All right, so simply drawing that, you just draw them. I mean, I've drawn them in random different positions, but it doesn't really matter. The idea is they're in different positions. Okay, so we just use 4. This is the frequency. Okay, this is the polarization. Yes, that's flying through space in parallel lines. That's a photon. Dumbass.
And this is an electron. So what specifically happens when this photon interacts with an electron? And why does, in some cases, it bounces 3 degrees when you need it to? In other cases...
So again, I never stated that there was, even when I said the word free electron, I'm saying, look, it's connected. It's trying to be part of something. It senses the proton. So again, I've made the assertion for at least over a year that there's no such thing as a free electron in the universe. It just doesn't happen. They just don't sit somewhere going, I'm free. Okay, there's always a bias somewhere, and they're charged objects, and they're going to move towards that bias. So they're either moving somewhere rather aggressively, and if they're staying in one general location, it's because they're caught in tension. So you have to draw that electron with the accompanying proton and the other accompanying electrons that are balancing its pressure, the charge pressure on the electron. And yes, when you hit something that's in an atmosphere, okay, if I hit the moon with an asteroid, the truth is the moon's not going to move in the direction that the asteroid hit it, because the moon is connected to the earth, and so it's going to move in some other direction than the exact momentum that the asteroid hits it in, because of the fact that it's in tension. I've said these words, I've said the word tension hundreds of times. So again, you're just such a liar to say this is all I've said. No, I've said a lot more than that. You liar.
It just goes right through, because you can't ever perform a which way experiment, even though they actually have done that. And in other cases, the photon is absorbed by the electron, because you need the electron to detect where the photon landed on the detector. So, yeah, explain that.
Whatever that is, right? So just garbage he doesn't draw.
Of course, I know you won't.
There's nothing to explain, liar. So now he's showing a picture of this, the corrupt wave experiment. Why didn't you make that argument again? You had the picture there. Why don't you make that shitty argument again? That's good science. Yeah, let's put way too agitated waves in and see and prove our point. It's diffraction. You're such a fucking piece of work. Anyway, so let's do a few comments just to get it done with. Alright, null point guy, I'm going to block you really soon, so I'm just giving you fair warning. Alright, you're always off the subject. You can't understand half of what the shit you write. You're mentioning Sky Scholar and Dissident Science, both people I have no use for. They're both fucking just as bad as conventional science. They're liars. They don't care about evidence. They just make shit up. I mean, fuck that kind of crap. If that's what physics you want, then go watch that physics and leave me the fuck alone, okay? And this commenting more than once in the same video, I hate that shit, and I especially hate it when it's impossible to read what the fuck you're typing, okay? So just fuck off or I'll block you, okay? I mean, there's just no real choice. DraftScience guy is more equipped for waves on a surfboard than anything to do with physics. Yeah, great. You made such a profoundly interesting argument there. No, you really didn't. You don't understand. I could say that about any fuckhead on the internet. I could just say, Professor Lewin's such an old fucking brain dead old fart. He can't do any physics. I can say all kinds of shit like that. Yeah, it's just crap. You fucking suck. Anyway, recently they say not only does Uranus have rings and circular objects around it, but now it is outgassing as well. What does that have to do with any of my videos? Oh, that's right, absolutely nothing. So if lots of assholes, he means outgassing, so I don't even know what that has anything to do with. So yeah, but just fuck off. I don't even want to read this. This is something to do with Electric Universe, no doubt. So just fuck you. Enough of that. I mean, really, I've done no videos on Uranus or any of that cosmological crapola. So, not interesting subject to me. They limit discussion to established science. Otherwise, everyone posting could have their own pet theory, and how would that help a person learning physics? Oh, so they think the physics forums are to help people learn. That's where people go. They don't watch the professors. No, they go to the physics forum to get the truth. Anyway, and regardless, the fact is that they don't like it because those arguments end up being a distraction because they have to defend their physics, and they don't want to defend it. You don't want to have to defend your lame, stupid assertions, and that's clearly what the troll is demonstrating. You don't want to have to sit there and say, oh yeah, our evidence really does kind of suck. It's really weak. Yeah, we never redid that Eddington experiment with any kind of decent technology, which is really lame. Yeah, we make these assertions about, oh yeah, photons disappear and shit, and well, we don't have to have any real good evidence for any of this crap. Photons are entangled because we say so. I mean, fuck you. All right. Banning everyone who disagrees with you is not the nature of debate, LOL. And there's no evidence I ban people for disagreeing with me. I ban people for wasting time, okay? I'll just remove it for now. Let's see if we can do any better than this. I doubt you won't do any better than this. But yeah, this is a waste of time, asshole. You don't see how it's just a waste of time to keep talking about this crap like you made an argument somewhere? No. I mean, I've shown my standards for why I ban people. It's because they can't stay on the subject. They can't make a relevant. All they can do is do ad hominem nonsense. So if you can't phrase your argument in any kind of civil manner, again, there's no evidence I've ever typed a comment on somebody else's video, okay, that wasn't within civil bounds. So if you can't do that, then yeah, you should be commenting on videos, okay? It's sort of your obligation. This is my house. You're coming over to my house and you're going to shit and burn holes in my fucking goddamn couch with your cigarettes and do all kinds of shit. No, fuck you. You got to do a little better than that. And so if you can't stay on the subject and make a rational argument and all you can do is throw insults, then fuck you. It's not that complicated. All right. Let's see. Man, I recently got to stop automatically. Okay, we already did that. Who cares about Mickey Farley? Blah, blah, blah. All right. Mickey Farley. Anyway. Okay. Enough of a video. But anyway. Yeah, I've said it before, but I mean, wave theory of photons is cooked. I've cooked it. It's done. It's fried. It's charred. It's over. It doesn't work, and this does. All right, until next time.